So, good morning, everyone. Today I'm going to present you my research, which goes by the name of Increase Human Robot Awareness in Collaborative Robotics Environments. So, why now this research? Why now it's important? Because with the advent of Industry 4.0, we have seen a shift of paradigm from mass production to mass customization. Now the client wants a product which is highly customizable. So, the industries require production lines which are flexible. Industry 4.0 tried to solve this problem introducing robots inside the production lines. However, the dream of flexibility is still far away from to be done, to be solved. And so, still the human agent is required inside these production facilities. So there is a production line which is composed of human and robots. Moreover, this production lines suffer from still human errors. Of course, human can make mistakes. They still have low production efficiency, but most importantly, whenever the production line needs to change because of a change in the market, in the demand, the human operator, which is typically not skilled, needs to reprogram the robot from the beginning for a different task. With our solution, we try to reduce the error, increase the production capability, but moreover, most importantly, trying to guarantee an intuitive programming method for non-skilled workers. How to do that? How the technology works? We try to introduce virtual reality inside industries, so the non-skilled worker is introduced in a simulated environment with the visor, and he's able to perform and show the task, how they are done to the human robot. However, the robot does not just learn how to do the action, but he understands the semantic. What does it mean? The semantic is the meaning of an action. When an action can be done, and what does this action entails. So, for example, the robot doesn't learn to pick the red cube, but he learned how to pick a cube. So he can generalize and abstract to more general situation and compose and use these single blocks of actions to compose more difficult tasks. So the robot actually understands the environment he's in and schedules the required actions to get to a final goal. The code is immediately transferred to the real robot, which understands the scene, and depending on the environment, he schedules the learned action in the virtual environment and reproduces and uses the actual skill that he has learned to get to a final goal. In this case, 2 piles of blocks. And the initial condition could be whatever. And so the robot here is autonomous and guarantees flexibility. What is the market we are focusing on? Of course, it's manufacturing industries, but more in particular for component assembly. For now, we are not still there, so we are focusing on an operation which is a bit simpler, kitting creation. Kitting creation is when you have a product, you need also the components for this product. So who actually compose the kit, in this case, would be the robot. The problem is changing the product means also changing the kit, and every time the operator should reprogram the robot for the changing kit. However, with this solution, changing the kit does not mean to reprogram the robot, but the robot accordingly entails and understands the different kit and reproduce the required action to reproduce it. So how the workflow works? So there is a worker, trains the robot first with teaching by demonstration, then it scans the particular product he would like to produce, the robot produces the kit, and the robot takes the kit and assembles the product. The product changes, the robot understands it, there is no need to reprogram the robot, and changes the kit accordingly, which is again sent to the human operator. I present myself, I'm Niccolò Lucci, a PhD student here at Consequently di Milano, and my research field is teaching by demonstration, exploiting semantic scene understanding for collaborative robotics. Thank you for your time. Maybe this is me, so if you later want to ask any question or want to learn more about my research topic, I would be glad to answer them.
The next presentation will be given by Michele Bolognini. The title is Applying Drones to Structural Inspections.